Hi, welcome to this Corbettmaths video. This Corbettmaths video is aimed at students preparing for the pure mathematics paper for GCSE Further Maths. If you're preparing for GCSE Further Maths and you're looking at those pure mathematics papers, there's always a big graphs question. Now that's not the name for it that you'll see in the specification. If you look at the specification, there'll be mentions of sketching quadratic graphs, sketching cubic graphs, finding the coordinates of turning points, using the second derivative or d2y over dx squared to determine the nature of those turning points, even finding the area under a curve by using integration. So they're the things that are mentioned in the specification whenever we look at these big graph questions. But if you look at those GCSE Further Maths papers, those pure mathematics papers in GCSE Further Maths, you'll notice there's always a big graphs question, and they follow these sort of parts where you have maybe part one where you've got to find the coordinates of where a curve crosses the x-axis or the y-axis. You then have to sketch that graph. You maybe need to find the coordinates of the turning points. Then you'll find the second derivative and show and verify it's either a maximum or a minimum, or perhaps you might even need to find the area under the curve. And in this video we're going to look at two examples. So I've got two big graph questions, or two big graph type questions that I've created. Okay, so let's have a look at our first question. So our first question says a curve has got the equation y equals, and then in brackets 4x plus 1, close brackets, and then in brackets x minus 2, close brackets squared. And part 1 says, write down the coordinates of the point where the graph meets the y-axis. So we need to write down the coordinates of the point where the graph meets or crosses the y-axis. So to find the coordinates of the point where a curve meets the y-axis, we just need to let x equal 0. Well, let x equal 0. So we'll substitute that into the equation and we'll find out what y is. So we're going to let x equal 0. So we've got y equals 4 times 0, that's 0, plus 1, that's equal to 1, so that's equal to 1. I'm just going to put that in a bracket there. And then in terms of the second bracket, we've got 0 take away 2, and 0 take away 2 is negative 2, so we then got negative 2 squared. And then remember our order of operations, we've got a square first, so negative 2 squared would be 4, and then times 1 would be 4. So that means that y is equal to 4. So that means the coordinates would be 0, the x coordinate, and then the y coordinate, which is 4, 0, 0, 4. And that's it. Also remember that the GCSE Further Maths paper is a calculator paper, so you can just type this into your calculator. You can put in 0 and just work that out, and you'll get that's equal to 4. So the coordinates of the point where the curve crosses the y-axis is 0, 4. That's the y-intercept, 0, 4. Okay, let's look at part 2. So part 2, so we've found where the curve meets the y-axis. Now we need to find the coordinates of the points where the curve meets the x-axis. So this time, if we're trying to find where it meets the x-axis, that's where the height's equal to 0. So y is equal to 0. So we're going to let y equal 0, and we're going to find the values of x. So let's do that. So the equation was, I'm just going to write that down here, y equals, and then in brackets, 4x plus 1, close brackets, and then x minus 2, close brackets. And we're going to let y equal 0. So we're going to get the 0 equals, and then in brackets 4x plus 1, close brackets, and then x minus 2, close brackets squared. So to solve this equation, we want to find when each of the brackets is going to equal 0. So let's start off with this bracket. We've got the 4x plus 1 equals 0. And then if we solve that, we get that 4x equals negative 1, taking away 1 from both sides of that equation. And then dividing by 4, we're going to get that x equals negative a quarter. So that's one of the brackets. Now let's have a look at the other bracket. We want to find when this bracket's going to be equal to 0. So we've got here x minus 2 equals 0. So that means that x is equal to 2. So that's fantastic. We've got our two values of x for whenever those brackets are equal to 0. Now, one thing I want to mention here is that if you watch the Corbettmaths video, the GCSE Further Maths video on sketching cubic graphs, I talk about these repeated roots whenever you've got a bracket squared. And what that means is that the curve won't cross the x-axis here. It'll touch the x-axis at 2, 0. But here we've just been asked to write down the coordinates of the points where the curve meets the x-axis. Well, let's write those down. We know for this one, it's going to be negative a quarter, and then y is equal to 0, so 0. And for this one, it'll be 2, 0. So they're the coordinates of the points where the curve meets the x-axis. It's going to cross at this point because it's just a single root, and this one's a repeated root, so it's going to touch at this one and then go either back up or back down depending on what the graph looks like. So that's fantastic. So we've done, in terms of this big graph question, we've found where that curve meets the y-axis, and we've found where the curve meets the x-axis. Okay, our next part. Okay, so we're now going back to those brackets, and we've been asked to expand and simplify 4x plus 1, close brackets, x minus 2, close bracket squared. So we want to expand this. And the reason that we're being asked to expand this is in our next part, we'll probably be asked to differentiate it, to find the coordinates of the turning points. So we'd obviously want to be able to expand it first. So as you see, these big graph questions will include lots of different parts of the GCSE Further Maths course. So let's expand and simplify this. So we've got our first bracket, 4x plus 1. And then we've got our second bracket squared, so that means that we've got our second bracket multiplied by itself. So I'm going to write it out twice. Whenever you've got a bracket squared, you've got two of them that you're timesing together, or you're timesing it by itself. Okay, so let's expand this. I'm going to expand these two brackets first of all. So we've got here in front 4x plus 1, close brackets. And then if we expand this, x times x is x squared. X times minus 2 is minus 2x. And then another minus 2x there would be minus 4x. And then finally, negative 2 times negative 2 is equal to 4, so plus 4. So that's fantastic. We've expanded those brackets. So now we just need to, we've expanded those brackets, and now we just need to times this bracket by 4x plus 1. So we're going to times everything in the bracket by 4x, and we're going to times everything in the bracket by 1, and then we'll just collect the like terms. So when we do that, we get timesing everything by 4x will be 4x cubed, because 4x times x squared is 4x cubed. 4x times minus 4x would be minus 16x squared. And finally, 4x times 4 would be plus 16x. So we've times everything in the brackets by 4x. Now we're going to times everything in the bracket by 1. So 1 times x squared would be plus x squared. 1 times minus 4x would be minus 4x. And 1 times 4 is equal to 4. So that's fantastic. We've expanded the brackets. Now we just need to collect the like terms. So when we do that, well, we've only got one term of x cubed, so that'll be 4x cubed. Now the x squared terms, we've got minus 16x squared plus 1x squared, that'll be minus 15x squared. Then our x terms, we've got 16x take away 4x, that'll be 12x, so plus 12x. And then finally we've got our plus 4 on the end. So that's it, we've expanded and simplified those brackets. And our answer would be 4x cubed minus 15x squared plus 12x plus 4. And we'll probably use this in our next part. You'll often find that with these big graph questions, they're quite nice in terms of the way that they guide you through the question sometimes by getting you to do one part and then the next part will say, hence do this. Okay. Our next bit. Our next bit, we've been asked to find the coordinates of the turning points of y equals, and then we've got our brackets again. Okay, so we want to find the coordinates of the turning points. So remember turning points, or some people call them stationary points, or those minimum points or maximum points. They're points where the graph, the gradient is equal to 0. So if you think of your x squared graph, it's got a turning point, the minimum point's at the bottom, the gradient is equal to 0. So if you want to find the coordinates of a turning point, you just differentiate the equation of the graph, the curve, and then you put it equal to 0. So let's differentiate this. And before we differentiate it, we'd want to expand it. And what's quite nice is if we think back to our last part, we've just done that. So 4x cubed minus 15x squared plus 12x plus 4. Okay, so this is equivalent to this if we just expanded our brackets. Now to find the coordinates of the turning points, because this is a cubic, it may have two turning points, and we want to find the coordinates of the turning points. So to find the coordinates of the turning points, we're going to differentiate this, and we're going to put it equal to 0. So dy by dx, the gradient function, that's what you get when you differentiate, will be equal to. And remember, we bring down the power, we times the coefficient by that power, so 4 times 3 is equal to 12. X, and then we reduce the power by 1. It was 3, it then goes down to 2. Next, minus 15x squared, we're going to bring down the power, so minus 15 times 2 would be minus 30 x, and then reduce the power by 1, so just x. And then plus 12x, well, differentiating that would just be 12, so plus 12, and differentiating 4 would be 0, so that's it. So we've now found what dy by dx is. Okay, dy by dx is equal to 12x squared minus 30x plus 12. Now we want to find the coordinates of the turning points. So that's when the gradient is equal to 0. At minimum points and at maximum points, the gradient at those particular points is equal to 0. So the gradient function will equal 0. So we're going to let this equal 0. So 12x squared minus 30x plus 12 equals 0. So we now want to solve this equation. So I've noticed here that everything is actually divisible by 6. We could divide everything by 6 here. So let's divide the whole equation by 6. 12x squared divided by 6 would be 2x squared. Minus 30x divided by 6 would be minus 5x. And 12 divided by 6 is 2, so plus 2. And then that's equal to 0. Okay, so we've just divided the equation by 6 to help us. Now we're going to try and factorize this and hopefully find our values for x. So if we factorize it, hopefully this will factorize. In theory, you may need to use completing the square perhaps to do that. So hopefully this will factorize. So we've got 2x squared. So I'm going to go for 2x and then x. If you like the split in the middle technique, you're more than welcome to use it, but I think this one's quite straightforward. We've got our 2 on the end here, so we're looking for two numbers that will times together to be 2, and when we put them in the brackets, we get our minus 5x. Because it's a minus 5x, they're both got to be negative, and I think I put the minus 2 there and the minus 1 there. And if you expand the brackets, 2x times x is 2x squared, 2x times minus 2 is minus 4x, minus 1 times x is minus 1x, which that'll be then minus the 5x in the middle, and minus 1 times minus 2 is equal to 2. That's great. So now we just want to solve this. So one solution would be whenever x is equal to 2. And here we've got our other one, which we've got the 2x minus 1 equals 0. I like to put it equal to 0 if it's not obvious. Add 1 to both sides to get the 2x equals 1, and divide by 2 to get the x equals a half. So that's fantastic. We've got our x coordinates of the turning points. Now we know our x coordinates. The question didn't just ask us for the x coordinates, it wants the coordinates of the turning points. So you'll want the x and the y coordinate. So to find the y coordinates, we're going to take these two x coordinates, the half and the 2, and we're going to substitute them in here because that'll tell us what y is. Because y is equal to, and then if we substitute them in, we can then find out what y is. And it's a calculator question, so that's quite nice. You can just type it in, but let's just work it out here anyway. Okay, so we're going to substitute these values of x in here to find the values of y. So let's start off with a half. So y would be equal to 4 times a half. Well, 4 times a half is equal to 2, plus 1 is equal to 3. That's a calculator question, as I mentioned a few times, so you could just work it out. And then here you've got a half minus 2, so it's going to be minus 1.5 or minus 1.5 or minus 3 over 2, minus 1.5, and then close brackets squared. And then we can just type this into our calculator, and when we work that out, we get an answer of 6.75, or 6 3/4, or 27 over 4, even as a top-heavy fraction. That's all fine. So and that means the coordinates of that turning point would be equal to a half, and then 6 3/4, or remember, just you can write another format. You could write it as 0.5 and 6.75, or even as a half and 27 over 4. You could write it all in any of those formats there, okay? But that's the coordinates of one of those turning points. Now let's have a look at the other one. Whenever x was equal to 2, so we now need to substitute x equals 2 into this equation to find out the value of y. So y is equal to 4 times 2, that's 8, plus 1, that's 9. And then we're going to times that by 2 take away 2, that's 0, squared. Well, 0 squared is 0, times 9 is 0, so y is equal to 0. So that means the coordinates of the other turning point would be 2, 0, 2, 0. And actually, I've kind of touched on that earlier. Whenever I talked about the repeated root, whenever we found out where it crossed the x-axis, it actually touched, because it was a repeated root, it had that squared, I knew it was going to touch the x-axis then go back up. So that meant that was going to be a turning point anyway. And it's quite useful to watch that Corbettmaths video on sketching cubic graphs, because I talk about things like that. And that'd be quite useful to know that as you're in these questions. Okay, so that's part 4 done. We've got the coordinates of the turning points. Okay, and then part 5, well, without actually looking at it, I'm going to predict it's going to be use calculus to work out whether each of those turning points is a maximum or minimum, and to then use calculus to justify it. So let's have a look and see. So part 5, use calculus to identify each turning point. So I'm just going to write the two turning points down here. They were a half and 6 3/4, and the other one was 2, 0. They were the coordinates of each turning point, and we want to use calculus to identify whether each turning point is a maximum or a minimum. Now, in looking at this graph and knowing actually it's a cubic graph, and it's going to be a positive x cubed graph, a positive 4x cubed graph, I know it's already going to have this shape here. So I know that the first turning point, the one furthest to the left, is going to be a maximum, and I know the second one's going to be a minimum. It's quite useful to know things like that, that if you expand these brackets, like we've done, and we got 4x cubed, that's a positive x cubed graph, so it's going to have that shape there. So the first turning point is a maximum, and the second one is a minimum. So I know straight away that this is going to be a maximum, and this is going to be a minimum. And it's quite useful to know that information. If you watch the Corbettmaths video, the GCSE Further Maths on sketching cubic graphs, we talk about that. But the question does say to use calculus to do that, so we have to use calculus to do that, but it's nice to actually sometimes know what the answer is going to be before you even do it. Okay, now we want to justify if each turning point is a minimum or maximum. So remember, to do that, we want to find what d2y over dx squared is. And if d2y over dx squared is bigger than 0, so if this is positive, then it's a minimum turning point, a minimum. If d2y over dx squared is less than 0, then it's a maximum. turning point. And I sometimes like to think of it being counterintuitive. The one that's positive is a minimum and the one that's negative is a maximum. It's kind of counterintuitive. Okay, so I've just copied these out from the previous part. I probably didn't need the y part, but I've just written down the y, the equation of the curve. We've got the dy by dx, what we got when we differentiated once. To find out if these turning points are minimum points or maximum points, what we do is we then find d2y over dx squared, so d2y over dx squared, by differentiating again. So we need to differentiate this. So to differentiate this, we're going to bring the power down. 12 times 2 is 24. And then we've got x. And it was to the power of 2. We're going to reduce that by 1 to then be to the power of 1. So we're just going to write 24x. And then we're going to differentiate minus 30x. That'll just be minus 30. So that's fantastic. We've now found out what d2y over dx squared is 24x minus 30. And that's going to help us find out whether each of these turning points is a minimum or a maximum turning point. And so to do that, we're going to substitute in the x coordinate. So we're going to substitute in a half, and we're going to substitute in 2 into this d2y over dx squared. And we'll figure out if the d2y over dx squared is positive or negative for each of those turning points. So let's go down and do that. Okay, so if we look at the coordinate 12, 6 3/4, we know that x is equal to half, x is equal to a half. And that means that d2y over dx squared, when we substitute a half into this, what would we get? And again, it's a calculator question, or we can just work it out because it's quite straightforward. 24 times a half is equal to 12. Take away 30 is equal to negative 18. So that means that d2y over dx squared for this first turning point is equal to negative 18. And negative 18 is less than 0, so that means that d2y over dx squared is less than 0, so that means that this is a maximum turning point, which we already talked about. We knew that was going to be the case, but we've now used calculus to prove it. So let's write that down. And I've just written down that since d2y over dx squared is less than 0, negative 18 is less than 0, that a half, 6 3/4, is a maximum turning point, or is a maximum. And because obviously in the question it says to use calculus to identify each turning point as a minimum or maximum, and it sometimes says to explain your answer, and we're just explaining it there. Okay, and we're now going to focus on the second point, the point 20. So the point 20. So the point 20, we want to find out if it's a minimum or maximum turning point. Just going to go up a bit so we can see d2y over dx squared. So we know that the x coordinate is equal to 2, so x is equal to 2. So that means that d2y over dx squared would be equal to, so x is equal to 2, 24 times 2 is equal to 48, take away 30 is equal to 18, so it's equal to 18. And remember that if it's positive, if d2y over dx squared is bigger than 0, it's a minimum turning point. So let's write that down. And that's it. I've just explained that since d2y over dx squared is bigger than 0, because it was positive, it's 18, that particular turning point, 20, is a minimum turning point. So that's fantastic. So we found out that the first one was a maximum, the half, 6 3/4, and we found out the second one, 20, was a minimum. And that's what we predicted anyway. And it's quite useful to know that that's the case from knowing the shape of the cubic graphs. But this question is really more about you knowing how to use d2y over dx squared, the second derivative, to show if a turning point is a maximum or minimum turning point. And that's it. Okay, so that's part 5. Part 6 now will probably be to sketch the graph. Okay, so let's use our information that we've worked out now in parts 1 to 5 to now actually sketch the graph. So we've found out where it crosses the y-axis. It crosses the y-axis at 0, 4. It crosses the x-axis, or meets the x-axis. Meets the x-axis is important, particularly for the second one, at the points negative 1/4, 0 and 2, 0. We also know it's a cubic graph, and we know cubic graphs, the positive x cubed graphs, will have this shape here. So actually we can use that information so far to do a little sketch. Let's do that to begin with, okay? So it's going to go up. It's going to cross at negative 1/4. It's going to cross here at 0, 4. It's going to come down. Now we know there's a minimum point at the point 20. So where it said it meets the x-axis, this repeated route here, we had this was 20, but we also found that 20 was a turning point. We found that out in part. We found that out in our last part, that 20 was a minimum point. So here, whenever we're sketching the 20 part, it's then going to touch and come back up again. And that's it. So that's our little sketch. Let's start labeling it, okay? So we had this point here. It crossed the x-axis at negative 1/4, 0. So this point here would be here, negative 1/4, 0. That point there. We know it crossed the y-axis here at the point 0, 4. We know it touched the x-axis again at the point 2, 0. And knowing that these repeated roots here, whenever you've got the squared on a cubic, it touches the x-axis at those particular points and then goes back up or back down depending on where it is. So we've got here, we've got where it crosses the y-axis, we've got where it meets the x-axis. Now let's write down the coordinates of the turning points. We've got our minimum point here at 2, 0. So we've already labelled that one. And let's do our maximum point. Our maximum point was the point 1/2, 6 3/4. So if we go across 1/2, it goes up to 6 3/4. My sketch isn't necessarily the best here. I'm actually just going to get rid of my curve and sketch it again. And that's the thing about these big graph questions, is sometimes here I don't really show that it's going up high enough. I'm just going to sketch this again, this part of the graph. So it's still coming up, it crosses the y-axis at 4, it comes up a bit further, and then it comes down and touches the x-axis there at 2, 0. So here the maximum point there was equal to 1/2, or 0.56.75. And that's it. And actually let's label the x-axis and the y-axis. So here we have got the shape of the cubic graph, and it's important to know those shapes and watching back the Corbettmaths video on sketching cubic graphs. We've got where it crosses the y-axis at the point 0, 4, where it meets the x-axis at -1/4, 0 and 2, 0. Also the fact it's got a maximum point here at 0.56.75 there, and it's got this minimum point here at 2, 0. And that's it. So that's an example of a big graph question where we have got finding where a curve meets the x-axis, the y-axis. We've had to expand some brackets. We've had to then use differentiation to work out the coordinates of the turning points. We've had to use the second derivative to find if a turning point is a maximum or a minimum turning point. And then we've also then had to sketch the graph as well. Okay, now let's have a look at another one. So our next one is going to have some similarities. This one actually does have a bit of integration in it as well, where we're going to need to find the area under the graph as well. So this one's a bit similar. It'll have lots of similar parts, and these big graph questions do often have a lot of points in common, but sometimes there's a little bit of variation, whereas this one has a bit of integration in it as well. So let's have a look at this one. So this time we're told a curve has got equation y equals -x² minus x plus 20. So whenever you're given those equations, sometimes it's actually useful to be able to visualize it to begin with. So this is a quadratic graph. It's got x squared, so it's not a cubic graph. Remember, your quadratic graphs are either a U-shape or N-shaped parabolas. It's a -x² one, so a -x² one will be this N-shaped parabola. So this graph here is an N-shaped parabola. It's an N-shaped graph, and it's useful to be able to spot those straight away. Okay, in our last one, I could look at this and see, well, if we expanded these brackets, you'd get x squared times 4x is 4x cubed. So I knew that was going to be a positive x cubed graph. I knew it was going to have that shape there. So it's quite useful in these big graph questions to visualize it if you can. Okay, part one. Part one says find the coordinates of the point where the graph crosses the y-axis. So to find where a graph crosses the y-axis, you let x equal 0, because obviously where it crosses the y-axis, it's whenever the x coordinate is 0. So let's substitute in 0 for x here. So we're going to have that y is equal to minus 0 squared, that's 0, minus 0 plus 20. So if x is equal to 0, y is equal to 20. So the coordinates of the point where the graph will cross the y-axis will be 0, 20. So that's quite straightforward. And in terms of these big graph questions, that probably would have been worth perhaps just 1 mark. It's quite straightforward. Okay, now let's have a look at our next part, part II. And part II says find the coordinates of the points of where the graph crosses the x-axis. So we've found where it crossed the y-axis. Now we need to find where it crosses the x-axis. And whenever a graph crosses the x-axis, the height is equal to 0. So y is equal to 0. So in terms of our equation, y is going to equal 0. So we're going to get the 0 equals minus x squared minus x plus 20. So to solve this equation, the first step I'm going to do is I'm going to bring everything to the left hand side. So I'm going to add x squared, add x, and take away 20 from both sides of the equation. Or you could just times the equation through by -1. Some people just times an equation by -1. It changes all the signs. But if you bring everything to the left hand side, we'd get x squared plus x minus 20 equals 0. So we're just adding x squared to both sides, adding x to both sides, and taking away 20 from both sides. Now we're going to factorize this. So let's factorize this and see what we get. So if we factorize this, that'll be bracket, 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 bracket equals 0. And to factorize this, we're going to put x's at the front of both brackets. We're looking for two numbers that times together to be -20 and add together to be 1, because it's plus x, that's plus 1x. So I'm thinking 5 and -4, so 5 and -4. And let's just check that. X times x is x squared. X times -4 is minus 4x. Plus 5x would be 1x, or just x. And then we've got our -20. And now to solve this, we just need to find when each bracket would equal 0. So here, x is equal to 4, and here x would be equal to -5. So that means the coordinates of the points where the curve crosses the x-axis will be -5, 0 and 4, 0. So that's fantastic. We've found the coordinates of those 2 points. We've done the first 2 parts. Okay, now let's look at the next part. Okay, part I, we've been asked to find the coordinates of the turning point. Now in terms of this graph, we remember it was an n-shaped parabola, so this turning point would be a maximum point. There might be a few different ways you can find the coordinates of that turning point, but I'm going to stick to calculus because in our next part it's often then to show there's a maximum point where we'll be using d2y over dx squared. Okay, so we're going to find dy by dx and we're going to let it equal 0 because we know that the gradient is equal to 0 at a turning point. So y was equal to, I'm just going to write the equation down again, minus x squared minus x plus 20. Just going to check that's what it was. And with these questions, sometimes they're spread over several pages, so you might need to go back to previous pages just to make sure and check what you've written down previously. So that's the equation of the curve. To find the coordinates of the turning point, and there's a whole video dedicated to that in Corbettmaths, feel free to have a look at that. But what we're going to do is we're going to differentiate it and put it equal to 0. So dy over dx, the gradient function, will be equal to, bringing the power down, minus 1 times 2 is minus 2, and then x, and then reduce the power by 1, so that'll just be x to the power of 1, so we're just going to write minus 2x. Differentiating minus x or minus 1x would be minus 1, and differentiating 20 would be 0. So that's it, we found what dy by dx is, it's minus 2x minus 1. So if we want to find the coordinates of the turning point, we know that dy by dx is equal to 0. So we know that this is equal to 0. The gradient is equal to 0 at a turning point. So we can just write 0 equals minus 2x minus 1. And then we can just solve this equation. I'm going to add 2x's to both sides to get that 2x equals -1, just adding 2x to both sides. Then I'm going to divide by 2, and we're going to get that x is equal to minus 1/2. So that means the x coordinate of the turning point is equal to -1/2. So it's going to be -1/2 something. And to find that something, the y coordinate, we just need to substitute this back into the equation. We just need to substitute it back into the equation of the curve. We know that y is equal to this. So we're going to do y is equal to minus, and then -1/2, the x coordinate, squared, minus, and then in brackets -1/2, and then plus 20. And you can just type that into your calculator. And when you do that, you get an answer of y is equal to 20.25 or 20 1/4, or I suppose even as a top heavy fraction, 81 quarters. I'm going to just run out as 20 1/4. And that's it. So that's the coordinates of the turning point, -1/2, 20 1/4, or I suppose you could write minus 0.5 and 20.25. And that's it. Okay, so we've done the third part of the question. Let's have a look at the fourth part. So the fourth part probably will be to show that that's a maximum point. So use calculus to identify the turning point as a minimum or maximum. Now we already know it's going to be a maximum turning point. It's a minus x squared graph, so it's that n-shaped parabola, so it has to be a maximum point. But let's use calculus to show it. And really this question is just checking you know that d2y over dx squared will help you show if it's a maximum or minimum turning point. Remember that if d2y over dx squared is bigger than 0, then it's going to be, if it's bigger than 0, then it's going to be a minimum. Always think of these as counterintuitive. It's positive, it's a minimum. But if it's negative, if d2y over dx squared is less than 0, then it's a maximum. It's the opposite. Okay, so we want to find out what d2y over dx squared is. So dy by dx, if we go back, was equal to minus 2x minus 1. So minus 2x minus 1. And if we want to then find the second derivative, we need just to differentiate again. So d2y over dx squared, differentiating again. Well, minus 2x, if you differentiate that, you get minus 2. And then differentiating minus 1 will just be 0. So d2y over dx squared is minus 2. We don't even need to substitute in the x coordinate this time. It's just minus 2. So because d2y, let's write that down, because d2y over dx squared is less than 0, it's negative, that means it's a maximum turning point. So that means that, what was the coordinate again? Minus 0.5, 20.25 is a maximum. And that's it. Okay, let's have a look at our next part. Okay, so part 5. Part 5, we've been asked to sketch the curve below. So we need to sketch the parabola below. So in terms of the parabola, let's think about it. We know where it crosses the y-axis. It crosses the y-axis at the point 0, 20. So 0, 20 there. Its maximum point, this time I'm going to consider that its maximum point was at minus a half 20.25. So the maximum point minus a half 20.25 will be slightly above. And we also know it crosses, I'm just going to label these, minus a half 20.25 is there, the maximum point. We know it crosses the y-axis at 0, 20. It's coming back down again. We also know it's a minus x squared graph. You know, it was y is equal to minus x squared minus x plus 20. We know it's a minus x squared graph, so we know it's that n-shaped parabola. We also know it crosses the x-axis at negative 5, 0 and 4, 0. So negative 5, 0 will be over here somewhere, and 4, 0 will be over here somewhere. So obviously this point's a bit further to the left and that one is to the right. So that's minus 5, 0 and 4, 0. Now, the only thing about these questions is sometimes I actually find it easier to sketch it before putting the points down, because sometimes it's hard to actually do the sketch through the points you've already plotted. So sometimes I like to do the n-shaped parabola and then start labeling the points. But let's try and go through these. And that's it. So that's my sketch, and it is just a sketch. And really, whenever the examiner's looking at it, they're looking for the key points, where it crosses the x-axis, where it crosses the y-axis, the maximum and minimum points being plotted, the fact that the graph is in the right location in terms of the fact that the maximum point is to the left of the y-axis, it was minus 0.5. So just like that. It doesn't have to be a perfect curve. Don't spend too long on your curve in terms of sketching it. You just obviously want it to have that n-shaped parabola. You're not obviously going back in on yourself or anything like that, but don't spend too long worrying about that graph, okay? And that's it. Okay, and now let's have a look at our next part, because sometimes these big graph questions, as well as having that differentiation, it might have a bit of integration. And here we've got part VI, or part 6. It says find the area enclosed by the curve and the x-axis. So we want to find the area enclosed by the curve and the x-axis. So in terms of the curve, here we've got the curve. Here we've got the x-axis. The enclosed area will be this area here, this shaded area here, okay? Because it's between the curve and the x-axis. It won't be any of these regions because they're not enclosed. And that's it. So we want to find this area here. And to find this area, the area enclosed by this curve and the x-axis, we're going to integrate the equation of the curve. We're going to integrate minus x squared minus x plus 20, and we're going to integrate it between the values of 4, the limits are going to be 4 and negative 5, where it crosses the x-axis. So we're going to find, let's write it down, we're going to find the integral of the curve, the equation of the curve, which was minus x squared minus x plus 20 with respect to x. You can put that in brackets if you wanted to, and we're going to integrate it between 4 and negative 5. And let's just check that we've got those values right, 4 and negative 5. And that's it. So to find that area, we're going to integrate the curve between 4 and negative 5. And again, if you want to recap that, feel free to go to Corbettmaths, go to the GCSE Further Maths section, scroll down and go down to the videos and integration, and you'll find videos on the definite integral, this. You'll find the videos on finding the area under a curve, the big examples with quadratics and cubics and things like that. Okay, but so what we want to do is we want to find the integral, the definite integral of minus x squared minus x plus 20 with respect to x between 4 and negative 5. And actually, just before we begin, I highly recommend you watch that Corbettmaths video on finding the definite integral, because I talk about the notation and how we do it in terms of, so whenever you integrate it, the first thing you do is put your equal sign down, and then we're going to integrate. So we're going to increase the power by 1. So instead of being 2, it's going to be x cubed. And then we're going to divide the coefficient by the new power. The coefficient was minus 1. We're going to divide it by 3, so it's then minus a third. So we've increased the power by 1 and divided by the new power. Okay, so we're going to do that. We're going to put it in a bracket, square brackets, and then we're going to then close brackets and put the limits on the end. So watching that video will be quite useful for you. But we've just integrated that first term. Now let's integrate the next term. So here we're going to increase the power by 1, so it's now x squared. And then we're going to divide the coefficient at minus 1 by the new power, so it's going to be minus a half. So if you integrate minus x, it's minus a half x squared. Okay, now let's integrate 20. So that'll be plus 20x. That's quite straightforward. Whenever you integrate just number type 20, it becomes 20x. And then remember, this is definite integration, so we don't need to write the plus c on the end here, because you're going to find out in a minute we're going to be taken away and they'd cancel out anyway. And I like to keep my answer similar to what you see in the mark schemes. So whenever you see these areas enclosed by the curve and the x-axis and so on, and you've got these definite integrals on the GCSE Further Maths mark scheme, they don't include the plus c there, so we're not going to include it here. But if you did, it would cancel out and they would probably just ignore it anyway. Okay, so we've then got this. Now what we're going to do is we've integrated. Now we're going to substitute in 4, we're going to substitute in -5, and we're going to take them away from each other. And then the answer will be the area under the curve. So let's do that. So we're going to substitute in 4, and it's a calculator question, remember, so we can type in -1/3 multiplied by 4 cubed, subtract 1/2 times 4 squared plus 20 times 4, and you can type that into your calculator, and also you can type this all in one go actually, but obviously just make sure you're doing it correctly. And also watch the Corbettmaths video on doing definite integration on your calculator so that you can check your answer. So whenever you do this, you can also do it in the calculator and check and just say, yeah, my matches up. Okay, so we then got subtract, and then we're going to substitute -5 into this. So -1/3 times -5 cubed, subtract 1/2 times -5 squared plus 20 times -5, close brackets, close brackets. Okay, so we can type this all in on our calculator in one go, or we can work out each bit separately. I'm going to work out each bit separately here. And whenever I work out this first part here, I get that's equal to 50 2/3, or 50.6666, and so on. Okay, subtract, and then if we work out this part, whenever we work out this part, we get that's equal to -70.83 recurring, so 8333, and so on. And then if we work out the subtraction, now just remember you can't type this all in one go, but just make sure you don't make any mistakes, maybe check it a couple of times. We get that's equal to 121.5. And that's it, that's the area under the curve. So that means that the area enclosed by the curve and the x-axis, this area here, is equal to, that area is equal to 121.5. And that's it. And also just to mention, if you do have a Casio calculator, here I've got the Casio FX991CW, I can press catalog, I can type function analysis, integration, and I can just type this into my calculator. And whenever I type that in and press equals, it just gives me the answer of 121.5. So I know I've done that right. And that's it. So that's it. So this Corbettmaths video has focused on those GCSE Further Maths, those pure mathematics papers when you've got these big graph questions. And it consists of lots of little skills, perhaps expand and free brackets, finding out where graphs cross the x-axis, the y-axis, knowing the shapes of cubic graphs, knowing the shapes of quadratic graphs, how to find the coordinates of turning points by differentiating, finding dy by dx and putting it equal to 0, and finding the x coordinate, putting that back into the equation of the curve to find the y coordinate, and then that'll give you the coordinate of that turning point. How to determine whether a turning point is a maximum or a minimum by finding d2y over dx squared, and then knowing that if that's bigger than 0, it's a minimum, but if it's less than 0, it's a maximum. And also how to answer questions like this whenever you want to find the area under a curve. And being able to answer those big graph questions is really, really important. And if you're preparing for those exams, I would say be ready for one. And that's it. And I really, really hope you found this video useful. Thank you. Cheers. Bye.